Hello. In the previous lessons, we learned about the different registers associated with the EEPROM operation. We also discussed about the steps involved in the different operations like erase and write only, and erase only. In this lesson, you shall use your learnings and implement an EEPROM driver. The driver shall support all the three operation modes. Those are erase and write, erase only, and write only. It exposes 4 functions to be consumed by the application module. These functions are EEPROM_init, EEPROM_read, EEPROM_write, and EEPROM_erase. For the implementation, we shall need the development board with the base circuitry and the USB adapter connected. As usual, the circuit schematics are provided for your download. Connect the development board to your development PC using a USB cable. The implementation of EEPROM driver is split into EEPROM.h header file and EEPROM.c source file. The header file is placed in the include directory and the EEPROM.c file is placed in the source directory. The header file contains the prototypes of the functions exposed by the EEPROM driver. The source file contains the implementation of the functions and a variable for internal uses. The include and the source directories also contain other files such as usart.h and usart.c, util.h and util.c, and several other .h and .c files. To test the EEPROM driver, we shall implement some test code in the prog.c file, which is placed in the source directory. The implementation in the file consumes the functions exposed by the driver. Before implementation, let's define the various EEPROM registers. These registers are defined in the res_map.h header file in the include directory. The offset of the 4 registers, those are EEARH, EEARL, EEDR, and EECR, are typecasted as volatile pointer to unsigned character and defined as macros. Let's also define macros to the 5 bits of the EECR register. These macros help in easy and readable code implementation. Create the header file EEPROM.h in the include directory. Write the statements, those avoid the multiple inclusion of the header file if it is done so mistakenly. The #if_endef checks for the definition of the macro _EEPROM_h_. If it is not defined, the content of the header file is included, else it is not. Then define the macro EEPROM_h with the #define statement. The programming modes of EEPROM is defined as an enum as such. Enum with typedef allows the programmer to define user-defined data types. Essentially, enums are integer data types. By default, the first member of the enum data type, that is erase_write, is initialized with the value 0. Then write_only with 1, and so on. Then declare the prototypes of the functions. Those are EEPROM_init, EEPROM_read, EEPROM_write, and EEPROM_erase. Check if everything is properly declared and there is no element missing that would lead to syntax error. Now let's create the source file, that is eeprom.c, in the source directory. Include the header file res_map.c where all the EEPROM registers are defined, and the EEPROM.h where the function prototypes are defined. Let's implement all the functions starting with the EEPROM_init. The function accepts the EEPROM programming mode, which is defined as the enum EEPROM_mode. Define it as the function parameter. There is no return value, so void EEPROM_init and EEPROM_mode in the parentheses. We shall save the programming mode in a global variable. Let's name the variable mode and define it as a enum EEPROM_mode. The variable mode is accessible to all the functions defined in the EEPROM.c file, but it must not be visible outside the file, hence defined as a static variable. In the function EEPROM_init, save the programming mode in the variable mode as such. The programming mode is set using the switch case statement as such. Define the case statements for the three modes. As discussed earlier, the programming modes erase and write, write only and erase only is configured by the values in the EEPM1 and EEPM0 bits in the EECR register. These bits are initialized as shown in the table with the help of bitwise AND and OR operations as such. Finally, the EEPROM ready interrupt is disabled by writing 0 to the EERIE bit in the EECR register. Just check for any mistake that would lead to compilation error and fix it if any. I shall stop the lecture here as it is getting longer. We shall implement the rest of the logic in the next lesson. See you then. Bye-bye.